a way for us to change variables, or sorry, change types of for data values or variables. And the truthiness is just, hey, if I think about the Boolean data type, there's, make sure there's, okay, cool. If I think about a Boolean data type, there are basically two types. There's true and false. And here, when I talk about truthiness, all I'm doing is trying to put every value into one of those two buckets. So let's get started and kind of see what all that entails. Okay, so types, we've seen a lot of types already, and so far most of the types that we've seen have been primitives, right? So numbers, strings, and booleans. There are a few other primitives types as well, including nulls, undefineds, and symbols. And we don't really talk about symbols in this course, and but you will see kind of nulls, undefineds, but primarily numbers, strings, and booleans. The reason why those are called primitive is to contrast them to other data types that are called complex data types, right? And the complex data types are functions, arrays, and objects. And really the most important difference between primitive and complex data types is that I cannot change a primitive data type, but I can change a complex data type. So we're going to talk a lot more about this end of next week when we talk about pass by reference versus pass by values. But the example that you can kind of, that you can keep in your head is just, if I have an array of 3 things and I want to add one more thing to that array, I can totally do that, right? I can modify, I can change that array. So therefore, the array is a complex data type. If I think about a number, right? I can't change a number, right? I can't change 6 to 7. Now, if I say let x equal 6, and I add 1 to x, well, now x equals 7. I've changed x, but I haven't changed 6, right? It's almost like a very kind of fundamental thing, like 6 is just 6, 7 is just 7. I can have a variable point to different values and represent different values at different times, but 6 will never change, right? Only the variable pointing to 6 can change. Similarly, on some of the problems that you may have already seen, you may have come across a problem that was like, hey, why don't you capitalize every other letter in a string? And if you try to just go into the string and change a letter, you're going to get back, it's basically not going to work. Instead, what you have to do is you have to recreate the entire string. And the reason for that is because, like numbers, strings are primitive data types, which means you cannot change them, right? So once you make a string, that is all it is ever going to be. If you ever want to change anything in that string, so to speak, you actually need to create a brand new string from scratch. So when we talk about coercion, then what we're really talking about is just this idea of, well, hey, if I have a string, how do I change it into, for example, a number, right? And this applies to any data types, but for these first few slides, we'll be talking primarily about how numbers and about the interplay between numbers and strings. So coercion occurs when we change one type of value to another type, and explicit coercion is actually, I think, something that's very easy to understand. Explicit just means we do it very, very clearly, right? We do it very explicitly. There's no kind of guesswork, or there's nothing kind of hidden about this kind of coercion, and we'll talk about what the hidden coercions look like in a few slides. But fundamentally, if I look at an example of coercion here, right, on line 6, I have num equals 10. If I do console log type of num, and then I do on line 9, I do let string equals capitalized string num, and I console log out string, and I do type of string, you'll notice that num is equal to 10. So when I console log out type of num, I get number. Afterwards, if I say let the variable lowercase string equals string num, notice how the s in string is capitalized on line 9. And remember what I talked about on Monday, right? That when you capitalize the first letter in a variable, usually the inference there is that, hey, I'm talking about a class. And in this case, we won't be going too deep into classes, but what you do need to know about classes is just that every data type has its own class. So here we see the string class, and in a few slides we'll also see examples of the number class and the Boolean class. But essentially here, by passing in num into the string class, all we're saying is, hey, can you do your best to convert this value, whatever num is, into a string and give us back that value? And so on line 9, on the right hand side, we're saying, I have this num variable, I have this num value, can you convert it into a string, give me back that value, and then I will store it in my variable lowercase string. Okay. On line 10, I then console log out that string, and it looks like 10 still. But when I do type of that string, I actually see that it now is no longer the number 10. It is the string 10, right? Or rather, it is a string with two characters, 1 and then 0. And so here, what we've done is we've actually taken this num equals 10, this number 10 on line 6, and we were able to change it into a string on line 10. Okay, and this works in either direction, right? If you think about changing something from A to B, we can also change it from B to A. So here on line 6, we have this string with 4 characters, 1, 0, 0, 0. If I console log out type of string, I'm going to get back a string type. On line 9 here, we see the number global class, right? So here, once again, number, and we pass in a value, and all we're saying is, hey, can you do your best to change whatever value this is into a number? And when I do that and I console log out num and type of num, I see that initially my string from line 6 is a string data type. On line 10, when I console log out after I convert it into a number, I get 1,000. And then when I console log out type of, I can see that it is now actually a number and no longer a string. Okay, so any questions so far? This is explicit coercion. The explicit just means on line 9 there, we explicitly tell you what class we're changing something to.
How many classes does JavaScript actually have?
So every data type has its own class, and then you can also make your own classes when you write code. So the answer is there's no limit. I mean, usually it's more like the data types. Every data type that we know about, functions, object, whatever, they have their own classes. But then very, very commonly, most people will write their own classes when you're writing on a big project. Cool. So moving along then, the not even contrasting, just another version of coercion is something called implicit coercion. And so the coercion part is still the same, right? We are still changing a value from one type to another type, but implicit coercion is something that JavaScript does for us behind the scenes. So let's just take a look at an example of that, right? Here on line 1, I have sum, and I set equal to the sum of 10 plus 20. On line 3, I have a variable called concatenated string, and I set it equal to the string 10 plus the string 20. Now, on line 1, it should be pretty clear, right? 10 plus 20 gives me 30. On line 3, it's also pretty clear, right? The string 10 plus the string 20 is going to give me the string 1020, right? Like I'm basically adding a bunch of letters together. But what happens when I try to add two different data types together, right? On line 5, I've added the number 10 plus the string 20. So what happens? And the answer is, in this case, and this is one of the unfortunate things where you just kind of need to keep in the back of your mind or know, whenever you're adding a string to a number, what JavaScript's going to do is JavaScript is actually going to convert both things to a number. JavaScript is going to coerce both things into a string first, and then concatenate it together. So on line 5 there, when I try to add a number 10 to the string 20, what JavaScript is going to do is it's going to take that number 10, coerce it into a string first, right? So now it's the string 10 plus the string 20, and then do the concatenation. And so that's why on line 5, that variable, not sure, that also prints out to be the string 1020. Okay, so if you're ever adding a number and a string together, just note that JavaScript is going to convert both things into a string first before it does the concatenation. Yep. So if we look at another example of this, right, on line 7, we have this variable called will be a string. And on the right-hand side, I have this string 10 plus 20, 30, 40, and 50, which are all numbers. Well, if I put myself in the shoes of the computer and as I go through this operation, well, what's the string 10 plus 20? That's the first step I have to solve. And so if I try to add the string 10 plus the number 20, I convert both things into a string, so it becomes 10 plus the string 20, and I get back the string 1020. The next step is what happens when I add the string 1020 to the number 30? well, then I convert 30 into a string, and then it becomes the string 102030, right? And so on and so forth. So by the time I get to the very end of it, what I really have is just one really massive string with every number having been converted into a character, right? Or into a letter, if you will. However, and this is why it's really important for us to be able to put ourselves in the shoes of the computer sometimes, is on line 7 now, I have the same exact operation, except now I'm doing 20 plus 30 plus 40 plus 30 plus 40, all numbers, plus the string 50. So if I would put myself in the shoes of the computer, the first operation that I do here is well, what's 10 plus 20? Well, those two are just numbers, so there's no coercion, right? Nothing needs to be changed. And so 10 plus 20 is just 30. Okay, great. Let's add 30 to the number 30. Well, that's just 60. Let's add 40 to 60. Great, that's just 100. And then let's add the string 50 to the number 100. Here's where coercion is going to come into play. I need to change that 100 into the string 100, and then I need to add it to the string 50, right? Or concatenate it with the string 50. And so therefore, when I print this out, I get back the string 10050. Yeah. And so it's just really important for us to know that when you do these operations, that you're following kind of the process and the order in which the computer is going to do it. Is there a question? Or is the party in the background somewhere? I'm sorry, is someone's mic on? I can't hear. Oh, great. Okay, thank you. Okay, any questions so far? Cool. So then,
sorry,
go
I
ahead.
had a quick question.
Yeah.
If you can go back to the last slide, it says the last line says console log type of also be a string.
Oh, that's a typo. I'm sorry. That should
Okay.
that should be also a string.
Okay.
Yeah, same variable. Cool. Sorry about that.
So David, expressions are evaluated from left to right. Is that correct?
Yes, expressions are read from left to right. But when you have an assignment operator, like we have on line 7 there, the right-hand side of the equal sign is evaluated first. It's just like basic math, right? Like if I say let x equals 1 plus 2, you would evaluate the 1 plus 2 first before you assign a value to the x. But then for the 1 plus 2, you read that from left to right.
Thank you.
Yep.
What would happen in the scenario where 30 is the string instead of 50? So
Yep.
20 and then, okay.
Sorry, finish your thought?
Oh, sorry, I muted myself again. Would it be read 10 plus 20, add that together, and then the string, and then you add everything else?
Yeah, so if the 30 was a string in this case and not 50, then 10 plus 20 would give you the number 30. And then 30, the number plus the string 30 will give you the string 3030. You would add 40, so then it becomes 303040. And you would add 50, so it becomes 30304050.
Got it. So everything to the right of 30 would be considered a string.
Right, because the string is going to change everything, is going to change that value and everything that comes after it into a string, because you're going to have a bunch of plus operations, and at least one of those things are going to be a string.
Yep, makes sense. Thanks.
Cool. Awesome. So now we're going to talk about comparison, and you'll see a lot written about double equal signs, which are 2 equal signs, versus 3 equal signs, which are triple equal signs. And basically the rule of thumb that I'm not going to go into all these examples here, but just know that for this class, and really in general in programming, always use 3 equal signs, the triple equal signs. And the reason why is because the triple equal signs is a lot more strict. And so what strictness means is that when I have a triple equal sign, what I'm saying is, hey, these two values have to be the same type, and they have to have the same value. What the double equal sign is, the double equal sign says, hey, if you're already the same type, then I'm just going to compare your values. But if you're not the same type, I'm going to try and convert you guys to the same type first, and then compare you. Now that sounds like a shortcut. It sounds like a nice handy feature, but the way that the double equal sign does coercions, or how it changes things, is actually very, very tricky and not what you expect, right? So if I look at line 6, right, when I compared the string true to the Boolean true, that gives you back false. Okay, and so there's a lot of rules on the way that double equal signs work, and in general, it's a headache to keep track of. And so in the vast majority of cases, and certainly for everything we do in this class, always use a triple equal signs when you're comparing things, because that just means, hey, everything needs to be the same type and have the same value. Okay, so just more like a good rule of thumb, just to keep in the back of your mind. Okay, so not the last, but another type of coercion we're talking about today is called Boolean coercion, right? So Booleans are a data type in JavaScript, which means that if I look on line 3 there, I see a capital B for Boolean, which means that Boolean, because it's a data type in JavaScript, it also comes with its own class, right? Or rather, it is a class in JavaScript. Booleans have only 2 possible values, true or false, nothing else. And so when we talk about truthiness, what it really means is it's just like a single word way of saying, hey, I want to coerce something into a Boolean, right? And when I coerce anything into a Boolean, I'm either going to get back a true value or a false value. So on line 3 there, when I coerce I am a string into a Boolean, I get back true. And in fact, most of the things that I coerce into Booleans are going to be true. And so you might hear this kind of slang almost that people use. Basically, any value for which if you convert it into a Boolean and it becomes true, that's called truthy. And for any value that if you convert into a Boolean, it becomes false, that kind of value is called falsy. And so most values are truthy, and I'm not going to go over this because it's actually a lot easier for us to remember which values are falsy in JavaScript. And there are only 6 possible values for there are only 6 possible falsy values in JavaScript. And so if your value is not one of these 6, then everything else in JavaScript is going to be truthy, right? As in everything else is going to if you coerce it into a Boolean, it's going to be true. So the only falsy values in JavaScript are an empty string, the number 0, nulls, undefined, and on line 11 we see this NaN. Notice how that's not a string, right? There's no quotes around it. NaN stands for not a number, and basically it's what happens if I try to coerce, let's say, my name, David, into a number class. The number class is going to say, hey, I can't coerce that into a number for you, right? It's going to give me back this NaN. And the last value, it's a bit kind of self-reflexive, right? But the 6th truthy value, the 6th falsy value is just false itself. Okay, and so all that means is that empty strings, zeros, nulls, undefined, not a numbers, and falses are the only falsy values in JavaScript, right? Which means that if you're not coercing one of these 6 things into a Boolean, everything else is going to give you true. And so if we think back to yesterday to the work that we did with our loops, right? Not just our for loops, but even also our if statements, right? Here on line 4, right? Usually we're in those parentheses, we say it's a conditional, right? And we expect to see, kind of a statement, right? Like if 1 is less than 6, right? Or if I is less than 2, right? Here on line 4, I don't even have a comparison. It's just if 5. And so what does a conditional really mean? A conditional is just like a fancy way of saying, hey, I'm going to give you something and I'm going to coerce it into a Boolean. And if that Boolean gives me back true, then I'm going to go. If it gives me back false, I'm going to skip it, or I'm going to stop. And so on line 4 here, if I look at this if statement, right, it says if 5, console log in the if, else console log in the else. Well, on line 4 there, right, that if, those parentheses next to the if, that's a conditional. And so basically all we're asking here is saying, hey, take whatever's in the parentheses and coerce it into a Boolean for me. So that means if I coerce 5 into a Boolean, is that going to give me true or false? Well, 5 is a number, right? And the only falsy number is 0, or not a number. And so therefore, I know that 5 is going to be truthy, which means that conditional is going to become true. And in the if statement, if the if part of it is true, that means I go into the if part of the code. And so when I run this, that's why I console log out in the if. On the other hand, if I don't even need to have like a number, right? Here, same exact idea. If I just say if apples, right? a random arbitrary string. Is that what, like, do I activate the if part of the clause or the else part of the clause? Well, the conditional says, great, let me take what's between the parentheses. In this case, it's the string apples, and let me coerce that into a Boolean for you. Is the string apples true or false? Well, it's not an empty string, so therefore it's true. And so therefore, once again, I am in the if part of the if else loop. And then lastly, another example, and then on line 10 through 14, we see the contrasting example, right? If 0, well, is 0, if I convert that into a conditional, or sorry, into a Boolean, is it true or false? It's false. So if the if part of my statement is false, that means I jump to the else part. And so therefore, for the first example, I will console log out yes, but for the second example, I will console log out no. Cool. All right. Any questions up to here? Cool. So just a few more things we're gonna do, and then we're gonna get you started on the workshops. There's also something in JavaScript that looks like an exclamation mark, but it's actually called a bang operator, B-A-N-G. And what the bang operator does is it just gives you the opposite of whatever Boolean you're looking for. So here, if I do bang true or bang ABC or 100 or an array or an object, well, just know that those things are all truthy values, right? Everything to the right of the exclamation mark or the bang operator is a truthy value, and therefore bang just says, give me the opposite Boolean of that. So if it's a truthy value, then bang will give you back false. And vice versa. If I, for example, if, for example, I then have another bang operator next to that bang operator, what we have is called a double bang operator. That just tells you to give me the opposite of the opposite, which and on line 4 there, as you can kind of see, right? What I've written down is basically just like using a double bang operator is the exact same thing as converting something into a Boolean, because you're saying give me the opposite Boolean of the opposite Boolean of the value, right? It's a little bit kind of mind twistish to think about, but just know that a single bang just says give me the opposite Boolean, and then the double bang just says give me that Boolean, right? So if I take, for example, on line 6, if I take that string ABC and do a double bang on it, the string ABC is a truthy value. So bang, a single bang for the string ABC is going to give me false, and then the second bang is give me the opposite of false, which is going to be true. And so that's the same as just converting the string ABC into a Boolean, which is going to give me back true. Everyone good here? All right. So the last two things we're going to talk about are logical operators. Logical operators, there's two kinds. There's and or. Okay, so we'll start with and first. And is written with this double ampersand that we see there on line 3. And what and does is and just is like a way for us to chain things together. And if you think about like the way that we use and in just normal English communications, right? If I say, hey, I need to bake a cake, can you go to the grocery store and get me milk and eggs and flour? That means I need all three things, right? If you come back with just eggs and flour, it's like, well, I can't bake the cake because I don't have everything I need, right? So the and is basically says I need everything in this list. And that's exactly how the logical and operator works in JavaScript as well. If I say, hey, on line 3, if I say, hey, if 10 and 0, well, that just basically is asking you, hey, is 10, is that truthy or falsy? And saying, well, if 10 is truthy, right? Great, let's check the second thing. Is 0 truthy or falsy? 0 is falsy. And so what and is trying to say is like, hey, is everything I'm checking, are they all truthy? And in this example on line 3 there, the answer is no, because the second thing I'm checking, that 0, that's falsy. And so therefore, line 3, that conditional evaluates to false, and therefore we go into the else clause. And so one more example of this and operator is something where we can be a lot more involved too. Here, if you on line 4, you can actually see me chain together these multiple values together with the and operator. I'm checking 10 and apples and 0 and no. Okay, And so what the AND operator is going to do here is going to move its way from left to right, and it's going to check everything. It's going to make sure it's truthy or falsy. Okay. 10, the first value, is that truthy or falsy? It's true. It's true. It's truthy. So then we move on to the next value, which is the string apples. Is that truthy or falsy? And the answer is it's truthy. So then I move on to the next variable, which is 0. And is 0 truthy or falsy? 0 is falsy. And so at that point, the AND operator is actually going to stop. It's not even going to check the fourth value because there's no point, right? The AND operator, in order for it to be true, every single thing in here has to be truthy. And so if as long as it finds at least one false value, it just says, great, stop. Don't tell me anymore. I don't need to know anymore because nothing else you have is going to change my answer. My answer is going to be false. And so therefore, we say that the AND operator, it returns either the first falsy value it encounters, or it returns the very last value if everything is truthy, right? If it managed to make its way all to the very end. And so if I look at the output of an AND operator, if it's false, then I know that the AND operator found at least one false value in that chain. But if it returns true, then I know that it went through the entire list and every single thing in that chain was truthy. If I look at line 7, for example, here I'm checking lucky, the string lucky, and the string number, and the number 7, right? So lucky, is that truthy or falsy? That's a non-empty string, so it's truthy. Then the string number is truthy as well, and so is the number 7. And so therefore, on line 7, it's going to return back to me the number 7. And so when I see that 7 as a return value, then I know that everything in that AND chain was truthy, right? Because otherwise it wouldn't have made it to the very last value. And the fact that it returned a truthy value to me means that everything else in that chain was also truthy. Does this make sense, everyone? Or any questions on this? Okay, cool. Cool. Then the very last thing we're talking about is just the exact opposite of AND, which is OR, right? When I think about the OR operator, here you see in JavaScript, it's written as 2 vertical lines or 2 pipe symbols. On most keyboards, the pipe symbol is located right beneath the backspace or the delete key on your keyboard on the right-hand side. In any case, for this OR operator, it's, once again, if I go back to my grocery store example, let's say I'm having a movie night, right? It's like, give me popcorn or chips or salsa, right? It means if you give me any of those 3 things, it's going to be good, right? Like I'm going to be happy. And so what OR does is OR returns either back the first truthy value it finds, because once it finds at least one truthy value, it says, just like the AND did, it says, I don't need to check anything else after it because I don't, like nothing else you have is going to change my answer, right? If I find at least one truthy value, it means I found something that's truthy and my OR condition is satisfied, right? A or B or C or D. If B is true, then I don't need to check or C or D anymore. Okay, so therefore the OR operator is going to return the first truthy value, or if it goes to the very end of the list like it does for line 7 here, it will return back the last value if everything is falsy. Right, so here on line 7 it goes through false, which is falsy, so I have to check the next thing. No, so that's false, so I have to check the next thing. Is 10 less than 0? No, it's not, so that's falsy. The last thing is not a number, that's falsy as well. And so I'm going to give you back not a number as my very last value. Right, so AND and OR are just kind of complements of each other, if you will. AND says, hey, I need to make sure everything is truthy, otherwise I'll give you back the first false value I find. And the OR operator says, hey, I just need at least one truthy value, so I'm going to give you back the first truthy value that I find. And that's pretty much it for today's lecture, right? So a lot of kind of very small, not unrelated, but definitely a lot of like kind of smaller things. But during the workshop, you'll get a chance to kind of play with all of them and kind of see how coercion works, right? Fundamentally, it's just changing things from one data type to another, whether it be from a string to a number, or as the last half of the slides show, if you're changing anything into a Boolean. Any questions before we put you on the workshops? Okay, then I will put everyone on the workshops. Just give me 1 second here.